Hello everyone, welcome to Math 186. We are going to start chapter 1, and the first section which we are going to look at is the Cartesian plane, the Cartesian coordinate. So let's get started. On your screen, you would see I would write down and followed my instructions in there and say, if you have any question during the lecture, do shoot me an email or you can put your question on the discussion forum. Okay, so let's get started with section 1. So for section 1 in here, many of you might be familiar with this section, which is called the rectangular coordinate. Okay, and whenever we talk about rectangular coordinate, we are talking about the x and y. So this is your x and y plane. Okay, so that's why this is also called the Cartesian plane, or we also call it as Cartesian coordinate, which is actually your x and y plane. Okay, now for your x and y plane, we have just drawn your x and y, but you can extend up the y to the negative position and you can extend up the x to the negative. So the first quadrant which you're looking at, so we are kind of going in the anti-clockwise direction, quadrant 1, quadrant 2, then quadrant 3, and quadrant 4. So this is kind of a brushing up your kind of a algebra skill in here. So we are going to the first coordinate, and then the second coordinate, then the third coordinate, and then the fourth one. Okay, for the first quadrant in here, your both x and y is positive. For your second coordinate in here, your x is a negative and y is a positive. Okay. X coordinate and y coordinate. We call this part to be your quadrants, and we call the x and y to be your coordinates. Okay. And then for your x and y coordinate for the quadrant 3, we have x to be negative and y is also negative. So all of these which you're seeing in here, that's your positive x and positive y. All what you're seeing in here towards the left is your negative x and negative y. Okay, so when you're looking at the fourth quadrant in here, this will be your x will be positive and y will be negative. X is positive and y is negative. Okay, so if we are going to pick some points, so let's say pick a point 1, 2. Then we pick a point -1, 3. Then we pick a point 1, -3. And then the next one will be another point, say -1 and -2. Okay. Now, when you pick these points, I want to know where are these points situated in your coordinate plane, right? So if you are looking at the first point, 1, 2, both your x and y is positive. So we would say that 1, 2 is situated in quadrant 1. Next, if we pick the point -1, 3, we would have -1 to be your x and +3 to be your y. So this is situated in quadrant 2. Okay. Next, we pick the point 1, -3. This point in here where your x is positive and y is negative is situated in quadrant 4. So this is quadrant 4. And then the point -1, -2. This is the point which is situated in quadrant 3. Because both of them is negative. Okay, so you're looking at the points, you're trying to figure out what is the location of these points in each of the quadrants. So you're kind of plotting it up and trying to put it down in the correct format in here. So if a question like this comes in your homework, you would be able to locate where these points are. There might be a question like this in your homework. Okay. The next one is something which you have seen before, is the distance formula. Okay. And the distance formula says that this is your hypotenuse. Okay. And this is your, so I'm going to name it as A, B, and C. This is your A, this is your B, this is your C, and this is your right triangle. So your A square plus B square equals to C square. And this comes in from the Pythagorean theorem, which you have done previously, seen previously in there. Okay, so in order to find the distance of a point, like between 2 points in there, then you can use the distance formula, which is given by d equals to square root of x2 minus x1 square plus y2 minus y1 square. And I'm going to show you how does this thing came in from. Okay, so suppose you have your x and y. X is in here. Okay, and you have a point, say right here, which is x1, y1. Okay, and you have another point in here, say x2, y2. And you want to know the distance between these 2 points. Okay, so in a situation like this, what you can do is you can drop a perpendicular right here, and then you can join the 2 points. And this point in here is actually, when you're dropping a perpendicular, this is your x1 and y1. So your x point in here is your x1, okay? And your y point in here is your y1. So when you're dropping the perpendicular, it's actually the perpendicular on the x-axis. Now, this point in here is your x2. So again, your x2 is right here, and your y2 is situated right here. Okay, so the distance between this part is your y2 minus y1, the difference between the y2 and y1. And for your x-axis, again, x2 minus x1 is your distance, right? So the difference between them. Okay, so what we can do, we can, using the Pythagorean theorem in here, we can say d square equals to, and d means, I'm going to put it in a different number. D is, this is what we are looking for, right? We want to know the distance between these 2 points, which is the absolute value, which is x2 minus x1, which is right here. Right here, that's your A. And then you can go in for the y2 minus y1, which is your B, right? So this was your A in here, this was your B in here, and what did the Pythagorean theorem say? A square plus B square equals to C square. In this case, we would have A square plus B square equals to D square. So your x2 minus x1 is B, your y2 minus y1 is your A in here. Okay, so we have B square plus A square, or which can also be written as A square plus B square. Commutator, that's your D square in here. So now your D square is equals to x2 minus x1 square plus y2 minus y1 square, and your D is now equals to square root of x2 minus x1 plus y2 minus y1. Since this is a square, your positive if it's a negative, it's going to square up and you would get a positive number in there. Okay, so let's do a quick example. We want to find the distance between the point -2, 1 and 3, 4. So this is going to be d equals to, and you're going to say your x, this is your x1, y1, x2, y2. So 3 minus a -2, and this thing goes in a square, plus 4 minus 1 square. Okay, and this would be given by 3 plus 2, and this is a 3 square. So you would have a 5 square plus a 3 square, which is going to be a 25 plus a 9, that would give you a 34. And of course, you can put this in your calculator and you would get a 5.83. So the distance between these 2 points in here, -2, 1 and 3, 4, is 5.83. Okay. The next one, which we are going to look at, is the midpoint formula. And again, something which you have seen before. And it's given by, so if you're looking at 2 points again, x1, y1, and x2, y2, you want to find the midpoint between these. It's given by, so the midpoint is given by x1 plus x2 over 2 plus y1 plus y2 over 2. That's the midpoint. So a quick example, we have points -3, -5, -3. And then we have 9, 3. We want to find the midpoint between the midpoint of them. We are going to take -5 plus 9 divided by 2, -3 plus 3 divided by 2. And this is given to be 9 minus 5 or 4. So we have a 2. And then -3 positive 3 gives you a 0. So the midpoint for this line segment is going to be 2, 0. And again, you can plot it out if you want to see how it goes. So we have a -5 and a -3. So the point will be in quadrant 3. So suppose somewhere in here, say -5 and a -3 is here. Okay. And then we have 9 and 3, which is in the quadrant 1. So we can take it right, 9 and 3 somewhere here. 9 and 3. So this is the line which we are looking at. So if you kind of join it up and see, and we want to find somewhere midway through it, and your midway in here will be somewhere right here. That's your 2, 0. That's the midpoint. Okay. Good. So this is what we have for this section right here. This is maybe the examples which we did would be useful for you to do the homework. So there might be a question where you would say, okay, find the distance between the 2 points, or there might be a question, find the length of one of the sides. So this is all you need. You would need your distance formula, you would need your midpoint formula. So these are the 2 main highlights for this section in here. If you have any questions, please put it down on the discussion format. If your peers can help you out, you can also email me for any detailed questions. Okay, so this brings end to section 1, and I am going to see you guys in section 2. Bye-bye.